Hello, everyone. This is Becca. I'll be going over the CS88 Fall 2021 final, specifically problem 6, Objective Judge. All right, let's jump right into the problem. So it says a debate judge is in charge of declaring the winner of a two-sided debate. In order to be more objective, the judge starts by drawing out all of the points in the debate as a concept tree. A point's children are subpoints that are related to that point. Then the judge creates another tree of identical structure called the winner's tree, where non-leaf nodes are marked as none and leaf nodes are marked as true if the for side has won that point, or false if the against side has won that point. Complete the function judge, which takes in a winner's tree T corresponding to a debate and returns true if the for side is the winner and false if the against side is the winner. The judge decides the for side has won a given point if they have won the majority of points directly below that point. If there is a tie, the against side wins that point. Using these rules, the judge can start at the leaves and move up to determine who won the point that is the root node and therefore the debate. Okay, so this is kind of a very big problem statement. So let's kind of look at the example tree that they give us, as well as the doc test, to kind of make sure we understand what the problem is asking us to do. So we can see here that on the left side, we have a concept tree, which, remember, it is not being used in the function, but it's kind of just provided for us to understand conceptually how these nodes relate to the debate. And then we have the winner's tree, which is actually what is passed into T, which is the only parameter that judge takes. So we can kind of see here that the concept tree contains a bunch of different topics that were debated. For example, is Berkeley better than Stanford or OSCE? And then in the winner's tree, we have the nodes of the tree being either none, true, or false. The true or false, remember from the problem, corresponds to which side won that particular point. So for example, for the OSCE topic, we can see that the corresponding node on the winner's tree is marked as true, which means that the for side won that particular point. On the other hand, if we look at the crossroads point, we can see that the corresponding node on the winner's tree is false, which means that the against side won that point. Okay, cool. Another thing to note about this particular example is that we can see that there's this kind of sports subtree here that contains itself multiple subpoints. So keep that in mind as we are thinking about implementing the judge function, that we won't always have straightforward leaf nodes here where we can see immediately who has won that particular point. Okay. So now let's look at the doc test before looking at the skeleton code, which is something that I highly recommend that you do just to make sure that you understand the problem and can kind of think about the implementation before you even start writing the code. Okay, so we can see that these first 4 doc tests are kind of just creating branches that we'll use in the actual tests of the code later, which are these last 2 lines, where we actually call the judge function, which is these 2 are what we want to pay attention to. So we can see that for the first call to judge, we take in a tree that has a root of none, and it has 3 branches that are made up of the subtrees 0.1, 0.2, and 0.3. So 0.1 is just a true node. 0.2 is a none root node, and it has 2 branches that are both true. And then finally, 0.3 is just a false node. Okay, so now let's go through this tree and kind of act as if we were the judge and we were trying to decide who won this particular debate. So right now, what T is currently this particular node, right? Because it contains the other subtrees, right? And what we want to do is we need to determine whether the for side or the against side has won the majority of the points, or sorry, the majority of the subpoints. So what are the subpoints? Well, the subpoints are this node, and this node. Just for reference, I'm going to block these out as being the subpoints that we want to look at. So let's look at the first subpoint. This subpoint is pretty straightforward because it's a leaf, right? We know right away who has won this point because it has a value of true, which means that the for side has won this point. Similarly, for this rightmost node over here, it is also a leaf, and we can see right away that the value of this node is false, which means that the against side won this point. But what about this middle node here? Notice that this middle node is not a leaf, and it contains branches that do have leaves, in this case, with the value of true and true. So we want to then kind of like recurse, right? And figure out whether this point was won by the for or against side. How do we determine whether the point was won by the for or against side? Well, we have to look at the subpoints, right? So the subpoints of this node, right? I will box them with the color pink so that you can kind of see. And we can see that both of these subpoints are marked as true, which means that the for side won both of these. And since the for side won 2 out of 2 of these subpoints, they have definitely won a majority. In fact, they have won all of the subpoints, which means that they have won the overall point. And we can say that the for side won this node here. And so now we want to go back up to originally where we were, which was this blue node, which was the root of the tree. And now we need to see who has won a majority of those subpoints. Well, we can see that the for side has won 2 out of 3, which are this node here and this node here, whereas the against side has won only 1 out of 3. Clearly, the for side has the majority with scoring 2 out of 3 of the points. And so we then say that this entire debate was won by the for side. So I'll just make a note of this. So debate winner is the for side. And since the problem says that if the for side wins, we should return true, then the judge function should then return true. And indeed, this is the case, since true is what we want judge to return based on the doc test. Okay, so now let's go over the second doc test. Okay. I will erase this for now. Okay. Okay. So in this case, when we're calling judge, we're going to call it on a tree with a root of none. And then once again, it has 3 branches, which are made up of the subtrees 0.1, 0.4, and 0.3. 0.1 is just a true node over here. 0.2 is, 0.4 rather, is a tree with a none root, and then 3 branches, which are false, true, and false. And then the final branch of the overall tree is 0.3, which is just a false node. Okay, so now once again, let's kind of take a look at what is happening. So we are currently looking at the top node, which is what we pass in as t, right? The root of the entire tree. And we want to determine who has won the majority of the points. How do we determine who has won a majority of the points? Well, we look at who has won each of the subpoints. So I will, all of the subpoints are essentially the branches of the current tree that we're looking at, right? So if we look at the very first branch, we can see that it's a leaf and it has a value of true. And remember from the problem, true means that the for side has won. So I'll make a note of that. We'll take a look at the second node later, but if we look temporarily for this third node, it's also kind of like a simpler case where it's a leaf, right? And we see immediately that it is that the against side has won since the tree has a value of false. So I'm going to say the against side has won this point. And then now going back to this middle, more complicated node, right? So since this middle node is not like a straightforward leaf node where we know immediately who has won that particular point, we then have to recursively determine who has won the point for that, or who has won that particular point. So how do we determine who has won that point? We look at who has won a majority of the subpoints. So currently we're looking at this point, and we want to look at these subpoints. Okay, so the first subpoint is just a leaf. It's false, which means the against side won that point, that subpoint. The second node is true, which means that the for side won that subpoint. And then finally, the third node is false, which means the against side won that subpoint. For this particular level of the tree that's I've boxed in pink, we can see that the against side has won a majority of the points with 2 out of 3, whereas the for side has only won 1 out of 3, which means that the overall winner of this point here in purple, or in pink, sorry, is the against side. And now that we've determined all of the winners of the subpoints that are boxed in blue, we can now see who the overall winner of the debate is. We can see that the against side has won 2 out of 3, whereas the for side has only won 1 out of 3. And so that means that the overall winner of the debate is the against side, since they have the majority of the points. And since the against side won, that means that we want to return false rather than true. And indeed, this checks out with the doc test, which also returns false. Okay, cool. So now that we have a better understanding of the problem, let's look at the skeleton code. Okay. So as I mentioned when we were kind of manually going through the problem here, this is a recursive problem, right? Because we don't know necessarily who has won a particular point if the point is it has subpoints. For example, this pink node here. On the other hand, if the node is a leaf, we can know immediately who won that point. For example, this node and this node. So we can kind of break up this if and else statement into the base case and the recursive case. So the base case in this case would be if T is a leaf, right? Because if T is a leaf, we know exactly who won. So we can write that in this first blank. So if T dot is leaf. And indeed, the skeleton code matches this kind of intuition here, where we return the value at that leaf, which makes sense, right? Because for example, if we had a tree that was a winner's tree that was just one node, right? The most simple basic case, and it was just, the value of it was just true, that means that the entire debate was won by the for side, right? On the other hand, and then that means we would want to return true, right? On the other hand, if the T that is passed in is just a single false node, we know that the against side won, and thus we should return false. So in other words, we're simply just returning the value of the tree that is given to us if it is a leaf. Okay. On the other hand, we can look now at the recursive case, which is inside of the else block. So inside of the else block, we can see that there's a variable called points1 that is set to 0. And you might be wondering, like, whose points are we tracking? Well, that's something that we can keep in mind as we're looking at the skeleton code. So I'll just write this down, like, whose points? Okay. And then after we set points1 to 0, we have this for loop that iterates through the branches of T. And then after that, we have this if else statement where we return true in some condition that we'll have to determine. And then otherwise we do something else. So since we know that the judge function either returns true or false, it's a pretty safe bet to put in this very last blank, return false, which means in the context of this problem that the against side won a majority of the points, or there was a tie. And remember as well, based on the problem statement, that we only return true in the case that the for side has won a majority of the points. And this is basically what will go in that if statement right there. So now the question is, how do we actually determine how many points the for side has right now, right? Well, it's a good thing that in the skeleton code, they provided us with this variable points1. So we can kind of like choose for ourselves and say that the points1 will keep track of, let me just make this a little bit smaller. Okay, so it will keep track of the points won by the for side. And then inside of this for loop, then we want to increment the points1 variable if the for side has won. Okay, so looking inside of this for loop, we see that there's an if statement. And in the case of the if statement, if the condition of the if statement is true, we want to do something. So the thing that we want to do, as I mentioned previously, is we want to increment the points1 at some point, right? Because we want to update this variable if the for side has won a subpoint. Okay, and how do we know that the if side or the for side has won a subpoint? Well, right now we're iterating through each of the subpoints, right? So the way that we determine whether that a particular point has been won is that we need to kind of recursively call the judge function on that branch, right? This is kind of what we were doing in the example, that tree that I have to the right here, right? So like, for example, when we started out, T was this node here. Let me do this in purple. T was this node, and the branches of T were the ones that were boxed in blue, right? So we're basically calling judge on each of those branches and determining using the judge function whether the for side has won, which means that it returns true, right? Which is why we can just do if judge B, because it returns either true or false. And in the case that the against side wins, then we return false. Okay. So once this for loop has finished executing, we know that points1 will contain the number of points that the for side has won, right? But how do we know whether that number of points, like let's say that the for side has won like 5 points. How do we know that that's the majority of the points? Well, let's think about what majority means, right? Majority means more than 50%, right? So, or more than 50% of the total. So how do we determine the total number of points? Well, the total number of points, as you can see here, is the number of branches that T has, right? So if we look back at our example at the blue box, we can see that if T is the root node, there are 3 branches, and that's also the total number of points, 3 points, right? So then we can use the length function that is built into Python, and we can do something like length of T dot branches. And what do we want to do with that? Well, like I said before, majority means that you have won more than 50% or more than half of the points, right? So we can calculate half or 50% by dividing the length by 2, right? And in order for the for side to have won a majority of the points, we need to say that the length of T dot branches divided by 2, or in other words, half of the points is less than the number of points won by the for side, which is stored by the points won variable. So you can either put this directly into the if statement, or you can use the official solution, which kind of just multiplies both sides by 2 and then puts points 1 on the left side. So in other words, we say 2 times points 1 is greater than the length of t dot branches. Okay. All right, so that is how you solve problem 6.